Hi everybody, it's Mrs. Zilbring. Please open up your packet to page 5. The title for this section actually got cut off. It's on page 4. But what we're doing today is graphs to represent situations. So, lots of situations can be modeled with graphs, and especially over the last 12 months or so with COVID, you've seen graphs all the time in the paper. But we're not going to be dealing with that. We're mostly going to be dealing with distance and speed. So what you have to do is read the problem, and then you sort of just have to match it up. I'm going to be using a lot of highlighters today. So if you have a highlighter or a colored pen or a marker, that would be good too. So let's try to think about these pieces. Gloria drives her daughter to school. Then she comes home. Okay? Another piece. She stays home until she has to go pick her daughter back from school. I guess I can use yellow. And then they both return home again. So now let's look at our graphs. We're dealing with time and distance. So when we drive to school, if you think about the like the odometer on your car, the distance, I'm not going to do that. We're talking about distance from home. So as we go to school, the distance from our home increases. So it's sort of like this. Starting at home, we're driving to school. So take a look at this graph right here. After school, after mom drives you to school, what do? What does mom do? She drives home. So look at this one. We drive to school and we come home. Then she doesn't go anywhere. That means her distance from home stays the same. Then in the afternoon, it's time for pickup again. We drive to school and we come home. Best way to show these is really just by example. So it's not a whole lot of math, it's a lot of interpreting. And I think it'll get easier as we go through them. Next one's about an airplane. I'll read it out loud first. As an airplane starts to land, it gradually slows down until it reaches its landing speed. It stays at this speed until it touches the ground, and after touching the ground, it quickly slows to a complete stop. You know, that's when the airplane hits on the brakes. Which graph represents this system? This situation. So again, I'm going to underline the different parts, and that's going to help us see how many pieces of the graph we would need. So in the air, it is gradually slowing down until it reaches its, let me erase here. The airplane gradually slows down until it reaches its landing speed. So I'm going to put some numbers to this one. It might be going down from, say, does the plane go 700 miles an hour? No, that seems too fast. I don't know. I'll just write it. Who cares? Let's say it slows down from 700 miles an hour to 400 miles an hour. I don't know. I'm just making up these numbers. Then it goes 400 miles an hour until it hits the ground. And if you've ever flown on an airplane, you know that it hits the ground fast. It stays at this speed until it touches the ground. After touching the ground, it quickly slows to a complete stop. That means I'm, again, making up these numbers, but the speed goes from 400 to 0. So let's think. Our plane is slowing down. So which of these is slowing down? Well, it's not these two. It's not C or D, because those are both speeding up. So let's look at these two graphs. We gradually slow down. And then we said, remember, we're going to be at a steady pace for a while. So take a look at graph A. We gradually slow down from like 700 to 400. Then we stay 400 for a while, but then we hit the brakes, and until you reach that stopping point, can you take off your seatbelt? We get to 0. Okay, moving along. Which of the following situations corresponds to this graph? So let's just look, and then we'll look at the choices. We've got time and speed. So this means we're speeding up, and I'm actually going to write that in. This is a good one. We're speeding up, and then we're slowing down. So let's think about this is 2 words. Speeding up. Okay, so let's see what this could be. Speeding up, slowing down. An object is lifted slowly, then lowered slowly. No, that doesn't sound right. A car accelerates from a stop, then gradually stops. That's a maybe. We'll put a question mark there. An object starts falling, accelerates, then falls slowly. That doesn't really make sense here. An object starts falling, so it speeds up. It accelerates, then falls slowly. Well, that one doesn't really make sense in this one either. An airplane climbs, and then it descends. We're talking about speeding up and slowing down. So the only choice is B. Next one is, I guess I need to make this a little smaller. Please take a look at this on your paper, since it was a little hard to get this all on one slide. I know it's a little small here. Temperature changes throughout the hours of a day. Early in the morning, the temperature increases slowly. So again, I'm gonna highlight the different pieces. At noon, the temperature rises sharply. Better get a smaller highlighter here. During the afternoon, the temperature stays the same. So I'd expect a piece that is flat. And at night, it drops off slowly. So let's see if we can see these pieces. The temperature increases slowly. Okay, well that looks like it's all of them. Then at noon, all of a sudden it gets a lot hotter. So a sharp increase would look like this. So that means I can eliminate letter A. Stays the same for several hours. Well, that's a key piece. That means it gets flat. So steady increase, sharp increase, and flat. And same thing, we've got a flat here. So C is no good. But then what happens as night falls? The temperature decreases slightly, so it has to go down. And the only one that could be is D. Which statement best tells the story of the graph? We have time and speed, so something happens, but we are speeding up. Okay, we're going faster. A car slowed to a stop? Nope. A car started from a stop? Maybe. A car maintained constant speed? We said, no, we're going faster. A car stopped, then started. That doesn't seem right either. So this is choice B. Again, we're talking about speed and time. So let's see. We have a steady speed. Then we're slowing down. Then we're increasing the speed. And then we're steady once again. I want you to pause it here, read the choices, and make your best guess. So the only one that's really going through all of these is the swimmer. The swimmer starts at steady, slows down, starts swimming again, and then steady but slower than before. This is back to the beginning. We're talking about distance from home. Home would be at the origin. So we're starting somewhere far away. So I'll write like far away. Then we come back home. Then for some reason we stay at home. We start again. We reach some point, and then we reach some point, and then once again, we don't move. So same thing as the last problem. Pause it here and see if you can figure out what I'm talking about. It really takes a minute just to read through them, but hopefully you see Trey goes home from a friend's house to home. He gets a coat, so he's home for a little bit. He rides to the store, and then he goes inside. You really just have to read through all of them. And like I said before, these are a lot of practice. So now we have maybe three last problems, but 2 problems where you're going to try to write your own. Draw a line graph that corresponds to the situation. An airplane accelerates constantly as it taxis on the runway, and then it takes off. It continues to accelerate at the same rate until it reaches its cruising altitude. So if you've ever been in an airplane, you might know this. On the runway, the airplane is driving, so it's going, and it is getting faster. But then the idea is once it takes off, it really goes fast. Maybe not that fast, but that's the best I can do. And then once your captain says we have reached our cruising altitude, then it's steady. I want you to give number 10 a try on your own, so pause it here and give it a try. So hopefully you got something like this. A bicyclist starts moving from a stop. That means he's speeding up. Then he travels at a constant speed. So once you reach, say, 10 or 12 miles an hour, you're steady. Slowing to a stop looks like that. We've got one more to do before practice problems. Tell which graph corresponds to the situation described below. Explain the reasons for your choice. William does warm-up stretches. Okay, so that's going to be really slow. Then he begins walking and speeds up to his jogging pace. He continues the jogging pace until he disappears around the corner. So I'm going to write some words in. Warm-up stretches, we're sort of going slowly. And then you begin walking, but then you speed up slowly. So that means you accelerate. And finally, we reach our jogging pace, which means you go at a steady pace. Okay, if you've ever jogged, you know at some point you hit like a good stride. So let's see. We're going slowly. We're getting faster and then slowing down. That doesn't make sense. Okay, speed. Warm up, slow down. This doesn't make sense either. We're not talking about stopping. So the only one this could be is the one in the middle. We're warming up, then we'd start running until we hit our pace, and then we go across. And then we are jogging at a steady pace until we disappear. Okay, thanks for hanging in there, guys.